and he worked with us for so long time. He's in the back, so thank you very much for the mentorship. And he's going to talk to us about integrated modularization and generative design for holistic design optimization.
Welcome everyone. My name is Sebastian Valencia. As I say, creo que no tienes prendido. Hello?
Yeah.
Okay. Hello everyone, my name is Sebastian Valencia. I'm a computer science and systems engineering student from National University of Colombia, of Medellin. Right. Today I'm going to talk about this project, but first of all, I want to tell you about why I started doing this. Everything begins when I was a kid, and I used to play with my brother at making CDs. We spent a lot of time just making CDs every time, the same CD, but yeah, it was funny every time. So that's the point when this hobby started for me. When I grew up, it doesn't change, it just transformed. I just started playing video games about urbanism and transportation. And in the other hand, I started being more interested into systems and how to use technology for the good of people. That's the reason why I ended up working as a computer science student for built environments. And that gave me the opportunity to work with Dr. Songsha and the other part of the team into the lab of smart and sustainable human-building interactions. We have one purpose in mind, that is, make built environments more sustainable and resilient. At the start of our work, we wondered, how can we make construction more sustainable? Usually, as you can see, typically a construction looks like this. You just start putting things from scratch on different schedules, and yeah, you just start everything from a raw state. But we wonder, how are we going to be the construction of the future? And I think the answer by now is prefabricated construction. Prefabricated construction is about manufacturing components offsite for later assembly into the site. As you can see, we have different kind of components. For example, panelized walls that are two-dimensional components and volumetric modules that are three-dimensional components. The benefits of prefabrication are that it improves safety, it reduces construction time and cost, and it minimizes material waste. But on the other hand, we have some challenges for applying prefabricated construction. The first one is how we design for prefabrication. It's a challenge because designers have to adopt that kind of paradigm and adapt to its workflow. The second one is, what is the optimal quantity of components? As you see, we have different kind of components, and one challenge is to decide how small or how big are going to be every component, and when to use volumetric modules and when to use panelized walls. There is a process called modularization that is about how we automate the segmentation of a building design for thinking about how to prefabricate it. Currently, automated modularization has been mainly developed only for panelized walls or only for volumetric modules, but not in an hybrid approach. And in hybrid approaches, they have not integrated yet some important things like openings, as you can see, for example, in this auditorium, those walls have openings for windows, those have not. So this is a really important information. And also semantic information of the rooms. For example, it's not the same to design a kitchen or design a bathroom. With that in mind, our objective was developing an automated workflow to generate hybrid modularization options for architectural BIM models, considering wall openings and room data. For this reason, we developed this complex, not complex, I don't know, methodology that I'm going to explain. The first part of the methodology is that you get an BIM model, architectural BIM model, and using visual programming, we extract the data of the walls, the rooms, and the openings into CSV files. The second part of this methodology is start designing a graph using that data collected. This graph is going to be useful to represent geometrical relationships into the components. Then, when we have the graph, we start finding which are the rooms into the graph, and then we decide if a room is eligible for being a volumetric module, that is a three-dimensional structure. If it is eligible for BM, then we calculate room similarity. For example, if in a room, if a full building, we have many bathrooms, probably it's going to be more useful to use volumetric models to create really similar bathrooms into all the building. But for example, if we are going to do an auditorium like this is an only auditorium for the entire building. So it has no sense to prefabricate it because it's not repetitive. Then we have to think about if we have enough similar rooms of the same type, and if not, we just use the panelized walls modularization engine that we are working on how to split a wall into two-dimensional parts for being prefabricated. And finally, we have to show the options, the different option design for the designer. For example, you can use 80% of panelized walls and 20% of volumetric modules of different approaches depending on the cost and the requirements of the construction. The results until this point is that we developed automated workflows for multiple data extraction. We consolidated data for creating tables and expressing their relationships, and we constructed a graph for analyzing eligible rooms to be modularized as BM. The future work we have is establishing rules for deciding whether to use a BM, designing a modularization engine for two-dimensional structures for panelized walls, setting restrictions that user can input. For example, the user can say the maximum weight for volumetric modules are these, the maximum length for panelized walls are these, depending on the city and the regulations of the country. And finally, we have to develop the render to show the generated options to the designer. These are some references. And I want to acknowledge my dear advisor that is behind in the auditorium, some other professors, as Jean and Carlos from Colombia that helped me in the development of the project. Of course, Juan Diego and Lucy for making this possible. And finally, to all my family and my friends in Colombia, and to my friends and support network here at UREP-C and West Lafayette. Thank you.
Any questions?
Thank you, Sebas, for your presentation. It's a really interesting topic. I would like to know what do you think about this kind of models, for example, in countries like Colombia. Maybe here it could be more developed, but I don't know how it could work, or if you think that this part of like systems is applied or will be good for applying in countries as Colombia.
Well, interesting question. I think that certainly it is applicable in Colombia, but usually in Colombia it's difficult to find really methodological process for construction. The most usual thing is that the family just start building another floor and another floor and another floor. But in complex constructions, it could be really useful to use this approach. And certainly in the next years, we will see more construction like that in bigger cities as Bogota, Medellin, Cali, etc.
So, thank you for your presentation. I would like to know some related with the last question, and it's how this modularization could be used in Colombia, for example, and when the weather is so extremely, and how this modularization could resist this kind of weather, like rains or windy or that kind of.
Well, thank you for your question. When we do the modularization process, we usually divide the walls into different kind of materials. For example, we define which walls are structural, which walls are not structural, and which walls are exterior or interior. So depending on these factors and the materials you have, construction is not my specialty, as you said, but you can take decisions with this information. If you don't want to modularize everything, you can just modularize the interior walls and just not modularize the structural or the exterior walls. It depends on the engineering and the design of the construction. But with this approach, we are trying to get freedom to the designer to decide what he wants to do, what they want to do.
Okay.
Okay, thank you.